Welcome to clickmyproject.com. This video demonstrates an image processing concept about visual sensitivity based low bitrate image compression algorithm. In this study, the authors present a visual sensitivity based low bitrate image compression algorithm. The algorithm combines both visual sensitivity and compression techniques so that a higher compression rate with satisfactory visual quality can be achieved. In the coding process, the image is divided into blocks and each block is classified as edge block, texture block and flat block. The edge blocks are important for the subjective quality of the decoded images. For flat blocks, a skipping scheme is employed to save the bits, and downsampling is employed on texture blocks. The flow of the project starts by dividing the input image into 8x8 blocks. To divide the input image into 8x8 blocks, the selected input image is resized so that it is divisible into 8x8 blocks. Next, we compute the gradient of the input image. The maximum of the gradient value is chosen to compute threshold values TH1 and TH2. TH1 is computed by multiplying the maximum of gradient value by 0.12 and TH2 is computed by multiplying the maximum of gradient value by 0.06. The 8x8 blocks of the input image are classified into edge block, texture block and flat block based on the following condition. If the block is greater than TH1 value, it is classified as edge block. If the block is less than TH1, it is classified as texture block. And if the block has a value greater than TH2, it is classified as flat block. After the classification of blocks into edge block, texture block and flat block, the blocks are encoded and finally decoded. For encoding edge blocks, a quantization level is selected which can preserve image visual quality from quantizing errors and also remove redundant information. Flat blocks are encoded one by one in a zigzag order, that is, after a block has been encoded, it will then be decoded immediately in order to construct a reference image gradually. The mean absolute difference is computed between the current block and a block in the searching window, and the block with the smallest MAD value is compared to a threshold T. If the MAD is equal to the threshold, the block is declared to be a matched block and is taken to be the reference block. In our proposed algorithm, the skip blocks will not be encoded, but their corresponding matching vectors are computed and encoded as auxiliary information. This auxiliary information is encoded using Huffman coding. The texture blocks are downsampled. On the decoder side, the inverse of the encoding process is performed to decode the bit stream. The JPEG microblock decompression step is employed to bit stream firstly. Then, for those downsampled blocks, simple bilinear interpolation is adopted to enhance the resolution. Now we'll see the demo of the project. Right-click on main.m file and select Run File. Select any image from the dataset folder and click the Open button. The process takes place by classifying the image blocks into edge block, texture block and flat block, and encoding the blocks and finally decoding it. So this is the input image I have selected. I have divided the input image into 8x8 blocks and I have classified it into edge block, texture block and flat block based on the conditions defined. After classification of each blocks into edge block, texture block and flat block, the blocks are encoded and finally decoded. This is the encoded image and this is the decoded image. The other images are the intermediate result of decompression process. These intermediate results are obtained by computing the mean absolute difference between the current block and a block in the searching window, and the block with the smallest mean absolute difference value is compared to a threshold t. If the mean absolute difference is equal to threshold, the block is declared to be matched and it is taken to be the reference block. JPEG micro block decompression step is employed to bitstream firstly. Then for those downsampled blocks, simple bilinear interpolation is adopted to enhance the resolution of the decoded image. We compared the performance of various algorithms on different types of images. PSNR and MSSIM values are computed. PSNR is computed as an objective to measure the quality of reconstructed images. We can observe that the PSNR values of our algorithm is higher than those of other algorithms. Mean edge structural similarity is also computed. We can observe that our proposed algorithm achieves the best performance in terms of MSSIM also. From this performance evaluation based on PSNR and MSSIM, we can conclude that our decoded image provides a better visual quality than other compression approaches at low bit rates. Thank you.